All right, good morning, everybody. Thank you for being here. My name is Robert Farrokhnia. I am a professor at Columbia Business and Engineering Schools. I am also the founding director of our Fintech initiative, and I have the pleasure of being here this morning. And what I wanted to do, kind of a change of pace, I was asked to do my best in giving you a quick 20-minute primer on what blockchain is and how it operates. Obviously, in the marketplace, there are a lot of people interested in understanding the fundamentals, and you can go online, look up, what is blockchain, a primer on blockchain, and what happens is you're confronted with 5 million hits that they're either, content that's either too long, too short, too technical, written by engineers for engineers, or worse, someone trying to sell you something, or God forbid, giving you wrong information. So one of the things I set out to do at the Fintech program at Columbia Business School is to kind of create this demystifying educational series that would give you a top-down understanding of how all this ecosystem, all these pieces actually work. So as managers or board members or executives or lawyers or consultants or whoever is interested in these topics would be able to ascertain what's real, what's not real, understand it from the top down. So I'm pleased to announce the official launch of our educational series. We kind of beta tested it over the past couple of months. I have one coming on machine learning and demystifying machine learning and AI in June, and in fall, more on demystifying blockchain, crypto, digital tokens, on cybersecurity, on quantum computing, and so on and so forth. So if you get a chance, check us out. But without further ado, let me give you kind of a quick background of how this whole industry came about and what is blockchain. Now, the fate of blockchain and digital currencies are kind of highly intertwined. And I hear people using blockchain and Bitcoin interchangeably, which is obviously not correct. In essence, blockchain is a foundational technology that enables the development of digital currency the way we really wanted them to work. And digital currencies are nothing new. I mean, we had a number of them launched as early as mid to late 80s. DigiCash and CyberCash, and they even IPO'd in 1996, starting in 96. But all of them failed for a variety of reasons, but some of which are truly fundamental. One, they always require this notion of trust. So if I issue a digital currency, and I'll ask all of you to trust me to do that, you might say, well, that professor, he sounds smart, and he might be trustable, but there's no way for you to fully trust me. You just got to know me. So this notion of centrality and the requirement of trust was the bane of all this digital currency. But more importantly, this notion of double spend. And let me explain to you what double spend is in a very simple, using a simple analogy. Whenever it comes to digital assets, whether they are music files or a text file or money or so on, the process by which you send something to someone is as follows. And I'd like you to think about the last time you sent an email with an attachment. And that process was quite simple. You go to your email client, you type in your colleague's email address, the subject line, the document you requested, you're typing a little message, and then you attach it by clicking on the little paperclip icon, finding the file, attaching it, and sending it over. As soon as you do that, something magical happens, and that is, what happens to the actual original document? Do you send the original document, or does it still sit on your computer? Well, the latter. So magically, you just created a copy, and you send a copy to your colleague, and the original sits on your computer. So that is obviously good for a Word document. But when it comes to money, that's a bit of a problem, because if I could do that, I'll be a very rich man. All I need to have one digital dollar, and I can send it to anyone and everyone that I wanted to. So in essence, that's the notion of double spend. How do you prevent sending a copy of the actual document as opposed to the real one? And how do you destroy the original one so the recipient knows you're the only person in the world who got access to that digital asset, let's say currency? So in essence, those were some of the challenges around creating digital currency. And lo and behold, over the past 20 to 40 years, amalgamation of different technologies came together that eventually led to Satoshi's famous paper released in 2008 that led to the development of Bitcoin, and it gave us new access to new tools when it comes to blockchain. So I'll give you the broad definition of blockchain, and then we are going to deconstruct it. So blockchain, in essence, allows you to keep track of transactions of digital assets, as I said, whether a music file or a Word document or actual money. And it does it in a way that's immutable, permanent, and highly transparent. And so anyone in the world can see it. And achieves consensus around the validity of the transaction and the transfer of value without requiring any trust. And it uses mathematics and cryptography to ensure that consensus is achieved. Now, let us, again, kind of deconstruct this. As I mentioned, all prior banking services or anything that has to do with money always required a central authority to validate transactions and keep record of everything, and everyone had to agree to that. But obviously, as the world is expanding and as we can interact with more and more people around the world, you may not necessarily be on the same platform. So you need certain resources to still be able to communicate with people you have never met before, and somehow trust them in a way that you don't need to meet them face to face to achieve that. Now, how does that work? Well, in a kind of a oxymoronic way, a blockchain, in essence, achieves trust by assuming zero trust. And the process, the way comes about is when transactions are happening, you need to be able to send information securely. And that's how cryptography and encryption comes into play. So I'm going to open a parenthesis, talk about that a little. Throughout the evolution of mankind, there was always this desire to send information securely and secretly from one person to the other. And going back to the days of Julius Caesar, we have been inventing methodologies to make codes, and obviously there were always people interested in breaking those codes. So you always had a bit of a cat and mouse game between code makers and code breakers. But all these methodologies, regardless of what they are, they always require the recipient and the sender to be able to have some secret agreement beforehand in how to encrypt and decrypt messages, how to send a secret message and how to be able to break that, garbled up message and get back to the original note. But that was the biggest problem because you can't send a document and send the code, the key to break that code at the same time. The same way you should never ever send an email to a colleague and say, oh, I just opened a bank account, this is the account number, and this is my password, because obviously email is highly insecure. So lo and behold, for over 1,000+ years, we've been confronted with that question, and lo and behold, a mental experiment comes about that leads to the development of this methodology in cryptography called public-private key pair. And how does that work? And I'll share with you the mental experiment, which I think is quite fascinating. So imagine I want to send a message to any one of you, and I haven't met most of you, if not all. And so the way I would do this is that I would put my message, I write my message, I put it in a nice briefcase, undestructible briefcase. I put a lock on it, and I give it to one of my trusted students in my lab, and I send it to you. And I put a padlock on it, and I don't share the key, obviously, so I keep the key. This briefcase gets to you, and obviously you can't open it because you don't have the access to the key. So what you would do in return is that you would put your own padlock on it, and you keep the key, and you send the briefcase back to me, again, using my trusted student as a courier. Now, I get this briefcase. Now I have two padlocks on it. And one is mine that I can actually open using my key, but the other one I can't open, and it doesn't matter to me because I know the content of the message. Or what I'll do, I'll open the padlock that I have the key to. Now the briefcase has only one padlock, which is yours, and you have the key. And I'll give it back to my student, and he or she comes to you, and all of a sudden you can read the message in the briefcase, and you and I have just communicated securely without having to exchange any keys. Obviously, a lot of latency is built into that, but that's okay. So in essence, again, very simplistic fashion, we just solved the problem I told you before, and that is sending information without us either knowing each other, trusting each other, or having had an opportunity to exchange keys. So in the digital world, again, in the world of cryptography and mathematics, we were able to solve that problem by using this public-private key mechanism by which I could send information securely to anyone and everyone in the world, and they could do the same, and more importantly, they can ascertain I am the true author of that document. I'm sure you all heard about digital signatures. In essence, they work like that. So that solves part of the problem, i.e., I'm able to send payments or digital assets to anyone I want to, and they can securely get it, and few people can intercept or read it, perhaps with the exception of NSA and so on. And we didn't need to know or trust each other. Now, the second part of the problem is the notion of centrality. Another interesting aspect of how blockchain came about is leveraging a true peer-to-peer network. Almost the same exact way that internet works. Internet is truly decentralized. There's no way you can shut it down because it's very resilient. Lots of nodes all around, so even if part of it goes down, the rest of the system still can operate and compensate. So part of the, obviously, if you read the history, part of the reason Satoshi Nakamoto, whoever he, she, or group of programmers are, or where, because Satoshi may have passed away, we don't know. Some of the Bitcoins that he has, or at least the early Bitcoins that still haven't been touched in quite some time, that's what people are thinking maybe he's no longer with us. But regardless, part of the, what he built exactly was coming out of the financial crisis we had in 2007, 2008, in which government was printing money, and there was always this central authority, the Fed or whoever, that would dictate how this whole system is going to work, and we all have to follow suit. So by creating a truly decentralized system to manage, send payments and so on, we achieved this notion of truly peer-to-peer and distributed system that's highly resilient, can never become too big to fail, and has a lot of resiliency, so no one can come down and shut it off if they don't like it. So, but again, that's more of a kind of a philosophy of how Satoshi developed, blockchain and Bitcoin on top of it. So obviously, the most, impressive use case of blockchain is around financial services, because unlike internet, which is mostly around transfer of information, with blockchain, we can actually transfer value as well, and be sure that that dollar that I sent to you, it gets destroyed on my quote-unquote wallet, and you're truly the only recipient of that one. And obviously, if you look at the evolution of money, typically it goes through multiple stages. First and foremost, people may be just using things like collectibles, seashells or gold or what have you, to use it as a mean to exchange value. And eventually it gets to a point that it achieves network effect. Just like, again, Bitcoin or any other currency out there, that more and more people believe it to be valuable enough to facilitate trade. And I should mention that there is, in the community, there's a bit of a discussion around the true nature of Bitcoin. Is Bitcoin having a bit of an identity crisis, i.e., is it truly a method to transfer payments or facilitate trade, or is it just a means to store value? I.e., currency right now, the dollars you may have in your pockets are highly fungible, and you can use it to buy or exchange anything, and the process is quite straightforward. Whereas you could achieve the same with gold, but there's a lot of delta between bid and ask, and exchanging it for other goods you may need is not as easy, but still acts as a way to store value. We could argue diamond the same thing, although diamond doesn't have a whole lot of inherent use cases other than the few industrial use cases and so on. But I digress. So getting back to blockchain, all of a sudden we have a mechanism that's, again, highly decentralized and doesn't require trust, and achieves trust through, as I said, mathematics and cryptography, and allows us to exchange value for any digital assets. But all of a sudden we can do a whole lot with this. And it also solves another problem around network effects. So all of a sudden, you can create an immutable list and ledger of anything you want it to be. For example, real estate assets. In emerging countries, there's always this challenge of not having access to the proper deed or title of a property. So you might buy something, and then it realizes, oh, shoot, you didn't buy it from the actual owner, you bought it from someone else who was claiming to be the owner. Well, if we have blockchain, all of a sudden we can have a highly secure ledger or kind of a database or list of transactions, and you can go all the way back to the original owner, making sure what you bought is the correct one. Has lots of use cases in clean energy, for example. Imagine, I'm living in a subdivision out in the suburb. I have, solar panels on my roof, and I'm generating electricity, but I'm generating more than I am consuming. So typically, I can sell it back to the utility. My counter would run, backward, and I get paid wholesale price for the electricity I'm selling to the utility. Now, my neighbor next door, almost same house, same scenario, but they are a large family, and they're consuming more than they can produce. So they have to buy retail from the utility. Wouldn't it be nice if I can sell my excess energy production to them, and they would buy it from me at a higher price than wholesale that I'm getting from my utility, and they would also save some money because they're paying less than retail rate. That sounds fantastic, and it's actually, a use case that's doable. Imagine scaling it on a much larger, community. So you can create mini and micro grids, and all these transactions, all these, who bought what from whom at what rate, are all driven by algorithms. So they're highly efficient and very cheaply and easily achieved. So you can, do lots of interesting things with it. Again, same thing for medical records, a lot of things around Internet of Things and so on and so forth. So now the evolution of blockchain, obviously. A good colleague of mine has this saying that Bitcoin was an experiment that got out of the lab too soon. It works in certain ways that we didn't predict it would work, but the same token, it has certain challenges around it that we are trying to solve. And I'm sure throughout this conference you hear a lot of people discussing various angles they're tackling to solve these problems and so on. And obviously, there's a lot of excitement. Look at out in the world, a lot of conversations around ICOs and token launches and so on and so forth. So as I'm sure you all read, you have to exercise caution, understanding what all these things are all about. But I'll give you, before my time is up, I'll give you one interesting element of blockchain, again, allowing us to do some things we couldn't do before. And obviously, I'm sure you hear about all the good things that blockchain allows us to do. Also keep in mind, blockchain allows us to do some bad things too. So hopefully, we won't get to see those. We'll only see the good things. But typically in the past, as we are creating more and more complex network systems, we need to create a common language for all these things to talk to each other. I'm sure you all heard of acronyms such as IP, TCP/IP, or SMTP, or POP, or IMAP. All these acronyms at the end with the letter P, and P stands for protocol. Protocol, in essence, is nothing but a common understanding, a common standard for us to achieve something. So POP, Post Office Protocol, or IMAP, these are simple email protocols that allow different systems to send a common way to send an email. So back in the days, if you were on Prodigy or AOL, you couldn't communicate between the two because they were closed-loop ecosystem. But now, as internet is developing, we need to have multiple of these, and for them to be able to communicate. And lots of unsung heroes sat down and wrote all these codes, all these protocols on a volunteer basis, and no one knows who they are because they kind of disappeared. There was no way for them to monetize their hard work. And other people came in and built application of top of those protocols, and those were the ones who won the day. You may recall Hotmail. That got sold for close to $400 million back in the mid-90s. So someone came in and created an email client on top of this whole protocol on email, and those were the ones that actually made the big bucks. Nowadays, here, we can build protocols using blockchain, but have the actual people who were working on this be able to monetize or participate in the potential upside by issuing these tokens, which again is just a simple mechanism within blockchain to exchange and trade value. And I'll give you one analogy, and that is, some of you may remember SETI, Search for Extraterrestrial Intelligence. which the name itself is always funny to me, as if we won't freak out if we find extraterrestrial life. We always have to make sure they're also intelligent. So SETI back in the days was this big radio telescope out in Puerto Rico, and it was recording every single signal coming, as many signals as they could coming from the universe. And the idea is if there's intelligent life out there, they're transmitting, and there's probably a pattern through that transmission that we can recognize. But the problem was there was so much coming their way, and again, in mid to late 90s, they didn't have enough processing power or storage capacity to keep all these things and analyze them at a later time. So they kind of came up with a clever solution, and that's to gamify it. It was a game. It was a tool or software you could download on your computer, and it would come with a packet of all these pre-recorded signals. And whenever your screensaver would go on your computer, the system would recognize, oh, this person is no longer sitting at their desk, so there's a lot of extra spare processing capacity being unused. So I'm going to use all of that, to kind of analyze all the things I need to analyze. It was very successful gamification of that idea, but again, there was no way for any of the original people to monetize that. Now, fast forward to now, we had a couple of examples like Filecoin or Golem that are almost using the same idea, but to allow anyone to be able to have, store files in a distributed, encrypted fashion all around. As opposed to going to Amazon, you could use this, or to use extra spare capacity that people may have on their computers to process data. Let's say you have a big data set, you need to run lots of analysis on it, and you don't want to pay Amazon big bucks to do it. Maybe this would be a mechanism for you to achieve that. So these are, again, just two quick examples of some of the things we could do, but more importantly, things we could, you can leverage blockchain to achieve all of these in a very efficient way. Obviously, the programs that run at Columbia, I need 2 days to give you all the foundations so you have a full understanding of all of this. So I hope you enjoyed this quick 20-minute presentation, and I'll be around. So if there are any questions, I'll be delighted to answer those. So with that, I thank you for your time, and I wish you a pleasant stay in San Francisco. Thank you.